Alright, let's look at terminal velocity and especially in skydiving. So we have a scenario where a skydiver jumps off an aeroplane and it starts to free fall. At this point, at time t equals to 0, let's assume the plane carrying the skydiver is not moving in any up-down direction. It's just going horizontal, and we're going to ignore all horizontal influence, horizontal velocity, horizontal forces. We're just going to not look at them. We're just going to focus on the vertical direction. So as the skydiver first jumps off at time t equals to 0, there is only one force acting on the skydiver, the weight. W equals to mg, as shown. And this weight does not change throughout the fall because it's the gravitational pull of the earth on the skydiver. Depending on where the skydiver is in the atmosphere, the value of g may differ, but we're just going to assume that it's the same. So it's a constant force, constant gravitational force. And at time equals to 0, we say that there is no air resistance. So air resistance is equals to 0. Now air resistance would increase based on the speed of the moving object. So in this case, the skydiver speed at the very beginning is 0. So at time t equals to 0, v naught or v0 is 0. So air resistance at time t equals to 0 is 0. So as the skydiver starts to plummet at time t equals to 1 second, he has gained some non-zero speed. So this is not equal to 0 and is bigger than v naught. At this point, there will be a non-zero air resistance. Alright, and we're going to include the air resistance here. It's just a very small air resistance at time t equals to 1. And as time progresses to time t equals to 10 seconds, we notice that this speed will continue to increase. It's going to be larger than when it's at time t equals to 1. And air resistance would also correspondingly be larger than when the air resistance when time is equals to 1 second. So this would increase a little bit more at time t equals to 10 seconds. Now we notice, or we recall, the Newton's second law, net force is equal to W, downward force, minus air resistance, upward force. So for time t equals to 1 second, the net force is as such. And I'm going to give the subscript 1 to denote the acceleration at time t equals to 1 second. Then, for here, at time t equals to 10 seconds, again it is W, the same W doesn't change, minus air resistance, R10. The air resistance at 10 seconds will be larger than that at 1 second because it's moving at a higher velocity. And this would have a resultant force W minus R10, which is given by MA subscript 10. Now at this point, we must recognize that R10 is bigger than R1. Therefore, A10 must be smaller than A1 because it has a smaller net force at time t equals to 10 seconds as compared to time t equals to 1 second. So here, when all else being equal, at time t equals to 30 seconds, we would assume that the skydiver has achieved terminal velocity. So what happens? T at 30 seconds is larger than t at 10 seconds, and it's actually what we call terminal velocity 1. I'm going to put a 1 there. I'm going to explain why later. So the upward air resistance R30 must be equal and opposite in direction to the weight. So the arrow length should be the same. And the net force now is W minus R30. Since they are equal in magnitude, it should give you 0. So at this point, acceleration at 30 seconds is 0. And the velocity v30 is actually terminal velocity. So for the graph, how would it look like? I have this graph, and it would look something like that. The gradient of a VT graph is acceleration. So we notice that acceleration is decreasing, getting smaller and smaller, so the gradient should get less and less steep. Until time t equals to 30, it should reach zero acceleration, so zero gradient, and that's what we get. So assuming at time t equals to 32, the parachutist opens the parachute, so it remain in terminal velocity for 2 seconds. So this is v30, and at time t equals to 32 seconds, when the parachute opens, it is moving, the parachutist or the skydiver is moving at a certain speed, which is very high. So with the bigger canopy now, the air resistance would increase significantly because it is moving at a very high speed. This is R32. So R32 is much larger than W. So the net force is actually R32 minus W, which is upward. So you will have a resultant force of MA32. Now A32 is directed upwards because R32 is up, it's larger, the resultant force is upwards. So A, acceleration, is upwards, and the motion of the skydiver is downwards. So in effect, the acceleration upwards would slow down the speed of this skydiver as it comes down. So maybe at time t equals to 32, the terminal velocity earlier is the same, t1, but because of this presence of a larger resistance, this air resistance R32 would slow down the skydiver, and the process of slowing down a skydiver would also have an effect on the air resistance, because air resistance is dependent on the speed. So as the speed reduces, the skydiver is slowing down because of larger air resistance. The air resistance also will start to decrease and decrease and decrease until it reaches a new terminal velocity. So let's assume that time 40 seconds is the point where it achieves a new terminal velocity. So at R40, this R40 will again be equal to its weight. So it should be equal and opposite in length of the weight arrow. And at this point, the net force, again, R40 minus W is equal to 0. So the acceleration at 40 must be equal to 0. And the velocity now at 40 seconds is smaller than the earlier terminal velocity at 32 seconds. And this is the new terminal velocity, I call it T2, which is much lower than T1. So maybe T1 is falling at a velocity of, say, 40 meters per second, which is way too dangerous for safe landing. So the opening of the parachute reduces the velocity to a new terminal velocity, say 8 meters per second, which is much more safer for a landing procedure. So here, how would the graph look like? So it starts to decelerate. At time t equals to 40 seconds, it will be V40, it reaches a new terminal velocity. So this is the new terminal velocity for a safe landing. So I hope this clarifies the process of skydiving with regards to terminal velocity. And there are two characteristics of terminal velocity that describes the velocity itself. First, it must be a maximum velocity or maximum speed, because many students have the notion that since acceleration is decreasing, the speed must be decreasing. No, the acceleration is still there. Although it's decreasing, it is still accelerating. So the speed is still accelerating. And the second characteristic of the terminal velocity is constant velocity. So it is actually doesn't change. So these are the two characteristics of a terminal velocity. And in the process of a skydiving, there are two terminal velocities that is achieved. The first before the parachute opens, the second after the parachute opens.